Okay, so when we're ordering rational numbers, it is helpful to think of what each number is in decimal form. So the first thing that I want to do is I want to look at 2 and 1/5 in decimal form. And so I'm going to write, my apologies. I'm going to write 2 and 1/5, and I'm going to convert it into a decimal form. So we know it's 2 and then I have to take 1/5 and I have to divide it out to figure out what that is in decimal form. That one's a pretty easy one to remember. 1/5 is the same as 2/10, or I could take 1 and divide it by 5 using long division. 5 goes into 1 no times, 5 goes into 10 2 times, 5 times 2 is 10. Or if I'm feeling super duper lazy this morning, I can go to my Desmos Scientific Calculator and I can, of course, divide it on there. And so when I divide 1/5, I end up with the value 2/10. And I'm going to wait for it to load here for a second. It doesn't want to load for me. I'm going to go ahead and let it load for a second while I finish this. And I know it's 2/10, like that. And now I'm looking for the cube root of 10. Now, the cube root of 8, I know that 2 to the third power is 8. So I know that the cube root of 8 is 2. But when I go to 3, 3 to the third power is 27. So the cube root of 27 is 3. And so I'm looking at a value somewhere between 2, which is the cube root of 27. Let me write it on a number line here. I know that 2 is the cube root of 8. My apologies. And 3 is the cube root of 27. And so when I'm thinking, well, where does the cube root of 10 belong? The cube root of 10 is going to be really, really close to the 2 because 8 is really, really close to 10. And so I'm thinking, wow, I think this might be smaller than 2 and 2/10. I think it's closer to 2 and 1/10, but I definitely want to check that value out. Let's see if Desmos has loaded. So just showing that 1 divided by 5 to get those 2/10 is in fact 2/10. But I can also see if I can figure out the cube root of 10. So I've estimated it at about 2 and 1/10, and I'm going to check that now. So I'm using my cube root function. I'm going to put in my 3. I'm going to come down here. I can right arrow over, or I could just click inside the box, and I'm going to find 10. Oh, the 0 is hidden under there. Let's see if I can just type the 0. I can. And actually, there it is. It was a little bit more than 1/10. It was 2 and 15 hundredths-ish. Now remember, this is an irrational number. It is not going to terminate. It is not going to end. It is not going to repeat in a pattern. And so this value is a little bit more than 2 and 1/10, but it's still less than 2 and 2/10. Because if I were to take this value and I were to compare it, this number 2.15443,469 is less than 2.2, even though it has more numbers. Because remember, if I have 2 and 2/10, which is just 2.2, that's followed by 0, 0, 0, 0, 0, 0. And if I think just cutting it off, 15 hundredths is less than 20 hundredths. And so this value, which was the same as 2 and 1/5, is greater because 20 is bigger than 15. And so I'm going to go back to my question here, and I see that it is greater. Now, this sign, this means less than. If I look at a number line, it's pointing to the smaller value. That is pointing to the lower number. It is less than. So this says 2 and 1/5 is less than, which is 2.2, is less than the cube root of 10. That is not true. This says the cube root of 10 is greater than. See how it's passing to the greater sign? That is saying it's greater than that. Well, I know that 2.15 is not greater than 2.2. That is a false statement. They are certainly not equal. And so I know that this I'm going to fix the test here in a second. By the time you get your video, it's going to say it correctly. This says that 2 and 1/5 is greater than the cube root of 10. So when you click on option 4, it is 2 and 1/5 is greater than the cube root of 10. And that is the correct statement. That is the true statement because 2.20 is greater than 2.1544, etc. All right. I hope this video was helpful.